Good afternoon, everyone. After that introduction, not much more to say. So let's jump into it. I'm going to start with a little video trailer. 10 years ago, WPI launched the nation's first undergraduate robotics major. And when we did that, we played this trailer at a first competition in front of 30,000 plus kids and their parents to introduce the program. So here goes.
WPI was first to combine classroom and hands-on learning. WPI pioneered the project-based approach to education. WPI was one of the original first sponsors, and now WPI is the first to offer a bachelor's degree in robotics engineering. We are at the start of a robotics revolution. Robots will soon transform every aspect of our lives. The world will need a new breed of engineer with the skills and imagination to develop machines far beyond today's reality. The world will need a new approach to education, a program that melds computer science, electrical and computer engineering, and mechanical engineering. That program exists at WPI. Be the first to earn a robotics engineering degree from the first program in the nation at WPI.
Pretty cool, eh? That still gives me goosebumps when I watch it. Okay, here's the roadmap. Let me give a little background first on WPI and then on robotics. WPI is a private university. It was founded in 1865, which makes us the third oldest engineering university in the United States. Mostly we do engineering, science, and management. And although we've historically been known as an undergraduate university, we also have graduate programs ever since '89. That's 1889. So we've been doing that for a while too. One of our hallmarks is our global projects. And the goal is to give 90% of our students an off-campus experience. So here is a map showing the places where we have global projects this year. Our students really get out. Okay, turning to robotics. In 2007, just as we were thinking about a robotics major, Scientific American published an article on a robot in every home that predicted that robots would become ubiquitous, just as the personal computer had. Well, the author wrote, "I can envision a future in which robotic devices will become part of our day-to-day lives." And the author knew a thing or two about PCs. That was Bill Gates. All right, well, he was right. And what's driving that is the doubling, the exponential growth in technology. So we see that the famous Moore's Law dictates how processors improve. Actually, Moore's Law is about the doubling of components on an IC, and they've doubled every year and a half to 2 years. And they're still at it. The death of Moore's Law is exaggerated, it seems. Crowder's Law for storage, Butter's Law for networking. So these all contribute to making robotics feasible. Unfortunately, our mechanical engineering colleagues haven't quite been able to improve motor performance at similar rates. Keep working on it, folks, please. So in the past, robotics has ridden Moore's Law, but in the future it's going to drive it. For example, take a laser rangefinder. Right? So it used to cost $20,000 for a laser rangefinder. Now you can get one for as little as 130 bucks. And in the future, when the demand for these devices is on the order of 60 million cars a year, each one with a couple of LiDARs, what's it going to cost? Who knows? But it'll probably be, in the $50 range, maybe even less.